Hi, welcome to Module 8, the network layer. This module as you can tell, it's kind of progressing up the OSI model layer. So you've done the physical layer, the data link layer. Now you're moving up to the network layer. So just keep in mind that's what we need to do. I don't need to do, but that's a good logical way of implementing this activity. So the question is, why do I want to do it? I mean, basically what we're going to learn in this chapter is a little bit about the network layer characteristics, information about the IPv4 packet, the IPv6 packet, and then we'll start talking about routing. Because now as you start getting up into the network layer, now you got to say, how do I communicate between networks? So just kind of start that introduction on how do I route data between networks. So let's look at the characteristics. Characteristics, just to remind you, what is that? That network layer is that third layer from the bottom, and it really only describes two things, IPv4 and IPv6. And if you remember the data link layer presentation, you actually passed down which of these two protocols to the data link layer so that it knows how to format the addressing necessary. Now, to accomplish end-to-end communications, the network performs four basic functions. It worries about addressing end devices, so each end device must be given a unique address. It encapsulates the protocol data unit from the transport layer, adding now the source and destination addressing, logical addressing, the IP addresses to move on. Then it does routing. Now, the network layer provides services that directs packets to a destination. To travel to other networks, it must be processed by a router. Now, the role of the router is basically to select the best paths. So that's done at this network layer, deciding which way it is. And then, of course, when it gets to a device, when it arrives at a network layer destination host, it's got to de-encapsulate. So we've wrapped information around it, the addressing around that, what we received from the previous layer, and then we're going to de-encapsulate that. So we've taken the transport layer's data, we've wrapped encapsulated IP addresses around it, and then when it gets to the destination, we de-encapsulate. We take off those IP addresses. If it matches, then we know at least we're at the right host, and then we can move that header and process the packet up to the transport layer. So now, the OSI layer 4 is unlike the transport layer in TCP/IP. So just keep that in mind a little bit. So here you've got a little bit of a video to show you how a packet gets routed. I suggest you to go through and play that. IP encapsulation, just like I said, you're taking the protocol data, the transport layer protocol data, the segment. So you're taking the segment from the transport layer, which includes the segment header along with the data that it received from the application. And that data comes in and we put on it and we encapsulate the IP header. That IP header basically just says what is the addressing. Now, the chapter does talk about network address translation because IPv4 is run out of addresses, and there's a way to, with the correct addressing, you can expand the usage of IPv4 addresses by transitioning, but we'll worry about all that in later modules. Because routers will actually implement packets, route packets between there. So what are some of the characteristics of Internet Protocol? Well, Internet Protocol, whoops, looks like I could have, no, I guess I'm still in the right section. Forgot about that. Okay. Characteristics, there are three basic characteristics of Internet Protocol. One, it's connectionless. That means there's no connection between the destination or the, so I don't have to set up an end-to-end connection between the two. It makes its best effort to deliver a package, but it's not guaranteed. And then, of course, it's media independent. So I don't care if it's run on copper, fiber, wireless. It doesn't really care. That's the data link layer and the physical layer's responsibility. The IP layer, the network layer, does not care. Now, connectionless. Connectionless means there's no dedicated end-to-end connection. So just keep that in mind. And this connectionless kind of give you a rough idea. I mean, I put the letter in the mailbox, but I have really no clue as to how does it get delivered. I know what the end device is, but I don't know how it's going to get there. Whether it goes by truck, by boat, by plane, 2 trucks, 3 trucks, 14 cities, you just don't know, and you don't care. You just know that I put it in the mailbox and I expect it to be delivered. On a network side, you send the packet, it runs through a whole lot of different networks and different routers and says, hey, based on the configuration of those routers and the traffic and other things that you can do to optimize the efficiency of a network, you're not guaranteed that one packet is going to follow the same message. You may get 2 different packets going 2 totally different destinations or different routes to get there. Best effort, it basically means what? I am going to maintain a connection. I'm going to, I don't have to have a lot of additional fields in the header to understand the connection. I mean, IP protocol doesn't really guarantee that all packets that are delivered are in fact received. That's going to be someone else's. I'm going to try, but it's some other protocol. It's another layer that's going to say, hey, I am missing segment X. It may be unreliable, but it is still trying to do the best delivery method possible. Media independent, pretty much like I said, it doesn't, I don't care whether it's over copper or optic or wireless. All of that stuff comes into play. You don't care. Now, there is a difference in the different media is that sometimes there is a maximum size that a particular media can transport. And how you indicate that to everybody is through the maximum transmission unit, the MTU. And that's just part of the information exchange between the data link and the network layer is identifying what that maximum size is. So just keep in mind that MTU, does change. Now, you can define that. Now, here's some characteristics of that first section. And then what I'm going to do is we'll go cut off this video and go on to the next one with IPv4 packet.